Good morning, good evening, good afternoon, everyone. Welcome in Salesforce Epics Hour. My name is Amit Chaudhary. I'm the founder and your host for Epics Hour. And today we are going to talk about dynamic bulkification. And we have a great speaker, Dan Appelman, who actually don't need any introduction. So let me hand over him for his presentation and the introduction.
Hi, folks. Welcome to my session on Apex Hours. Thank you, Amit, for inviting me. I think it's been a few years since I've been here. Let me introduce myself before I talk about the subject for those who aren't familiar. And I'm doing it just to sort of give you a background and some context because I'm going to talk about some things that I've seen in the context of my experience. So I am a CTO and co-founder of a company called Full Circle Insights. This is a Salesforce ISV partner that does marketing analytics. I'm a Salesforce MVP. I think this is my 10th year. It's been just an amazing ride, amazing honor to do that. I'm on Twitter. I only tweet very, very rarely. My main websites are advancedapex.com, which is articles on Apex and discussing issues on my book. There's also a link here to my Pluralsight courses. I have a number of Pluralsight courses on Salesforce topics, such as getting started with Salesforce development and introduction to JavaScript for Salesforce developers, and a sort of an introduction to Apex programming for people coming in from other languages. And I also run a website called searchtheforest.com, which is a Google custom search for all things Salesforce. So when you're searching on Google, instead of having to type in Salesforce ... you can just type in what you're looking for, and it will only search Salesforce related sites. So that's who I am. And what I'm going to talk about today is dynamic bulkification. And you might be saying, wait a minute, I've never heard of dynamic bulkification. That's a strange term. And you might be feeling bad that you haven't heard about that, but please don't feel bad, because as far as I can tell, this is the first time it's ever been used. In fact, I Googled it recently and there are no results on dynamic bulkification. So the reason you haven't heard about it before is because I'm inventing it right now. You're the first people to hear about it. Now, inventing a new technical term is a grave responsibility. It's one I take very seriously. I'm just kidding. I'm doing it because it seems to be the best term to describe something that we've been seeing lately as an ISV partner, and a solution we came up to deal with it. So it is a new solution to what is a relatively new problem, one that we've been seeing more and more over the past 6 months on the platform as an ISV partner working with many, many customers. So let me give you some background. First of all, when we talk about Apex as an ISV partner, things are a little different. And I want to stress what I'm going to talk about now does not only apply to ISV partners. You may be seeing this in your own org. You may not. But the reason we see it is because we deal with many different companies, and the Apex we use is in some ways different from the Apex you use. We'll use different design patterns. For example, if you're an ISV partner, you will use dynamic SOQL and dynamic DML in many cases where it would be in a regular or in a non-ISV scenario, you would want to use static DML and static SOQL. We also deal with different limitations. In some cases, we have our own set of limits to deal with. In some cases, we're dealing with issues that you wouldn't see if you're developing for a specific org. And we do see a lot of orgs, and every org is different. And perhaps the biggest defining factor is that our packages need to run everywhere. So when you're building for a single org, you can build for that org. You only need to deal with issues that org is seeing. But we have to deal with issues on hundreds of orgs, and they're all different. So we end up writing a lot of defensive Apex, and we end up seeing situations that are unusual, which is sort of how we got to this problem of discovering the need for dynamic bulkification. Another thing, and this is true both for ISV partners and for you, is that things are always different in production. This is a truth in Salesforce that no matter how good a job you do, testing and validating and building in your sandboxes and scratch orgs, when you go live in production, things are going to be different. That's because, first of all, you will often have more data in a production org. You will have traffic. Things will be happening in a production org that you can't really replicate in a sandbox. Multiple users, multiple integrations. And in many cases, key integrations are not turned on with a sandbox. So for example, if you have an external marketing automation system that is busy inserting leads, it's going to be doing that in production. It's not going to be doing that to a sandbox, and you're probably not going to be replicating that. So you're going to miss things in production, and there are certain classes of problems that you may only discover once you push your Apex to production. And this is just the nature of developing on the Salesforce platform. So I mentioned integrations. Let's talk about integrations. Integrations, we're talking about outside services that connect to Salesforce, and that's primarily those that are inserting data into Salesforce. And the one we see, being a marketing analytics ISV, we see primarily marketing automation systems or sales automation systems. And of course, you probably do too, because Salesforce was originally a CRM. It's still an excellent CRM. And it's very common for a company that's using Salesforce for sales operations, that very common application, to be using external integrations that are doing external intelligence or inserting leads or contacts or campaign members or all kinds of operations. So how do those integrations work? How do they connect into Salesforce? Well, originally, they used SOAP. Now, SOAP, or Simple Object Access Protocol, its characteristics are, first of all, it tended to use XML. It didn't have to, but I've never seen a SOAP implementation that doesn't use XML. And XML is not the easiest thing to work with. Because of that, and because of the SOAP protocol in general, it tends to be rather complex and hard to implement. There are generally three main SOAP integration points. There's what's called the Enterprise API, which is a SOAP interface that is specific to your organization, which means that the integration company integrating into your org would actually see your custom objects and your metadata and be able to code directly against it. Enterprise API is generally something you would use when you're building your own integration. A third-party integration would use something called the Platform API, which is an API that is generic to all orgs. So it works with S objects instead of your specific custom object. And of course, it's possible to expose your own SOAP endpoints that could be used by an integration. Now, one of the characteristics of SOAP is that all operations to SOAP, all DML operations, use arrays. So if you're building an integration into Salesforce using SOAP, you're going to be passing arrays of objects. It's the only way to do it, which means that the idea of bulk operations, the idea of processing records in bulk it's obvious. It's sort of right there in your face, easy to do. Everybody knows how to do it. So it's SOAP is complicated, but performing operations in bulk is easy and obvious. Now, REST is the newer API, and it's very popular for a number of reasons. First of all, it uses JSON, which is JavaScript standard object notation. Very easy to use, very common, lots of libraries that support it. And REST is easy to implement. You basically specify all of the information in a URL or in post data, and you perform standard HTTP operations such as GET, POST, PATCH, and so on. When you read the REST documentation, you'll see that it introduces how to work with individual records. So the URL would have a specific record ID in it when you wanted to work with that record. It is possible to do bulk operations or composite operations in REST, but a lot of integration developers will never see it. right? Because it's farther down. It's well after it's covered all the ways to do individual record operations. You know how it is with developers. You look through the documentation. As soon as you find the way to do it, say, okay, I'm done. You're not going to read the entire document, the entire, specification for the API. It's like, you're good to go. So as a result, integrations that use REST often do not perform bulk operations. They perform operations one record at a time. So what does this look like when you're doing a lot of them, right? And some of these systems, some of these sales and marketing automation systems work with a lot of records. So now we're talking, instead of once every 10 seconds inserting 200 records, you'll have 200 API calls inside of those 10 seconds. And we've actually seen numbers close to that. So you really can have these high frequency operations. So what happens when you do this? Well, on a simple org, one that has no triggers, no automation, it's going to be fine. Salesforce was designed for efficient processing of bulk operations, but it's still a very robust system. It can handle a lot of transactions, a lot of traffic. So things will work. You'll have an integration, make a call, and then Salesforce will perform its operation, and it can handle the traffic. And this is probably how these integration companies test their integrations, right? They don't test them on big complex orgs with lots of Apex or automation. They just test them, I would think, on fairly simple, clean orgs. So everything's fine. But what happens when you start getting into the real world? And in the real world, you know how it is with companies. They put additional Apex triggers, perform additional automation. They're using Process Builder, they're using flows, and so on. Well, suddenly, the time for Salesforce to process that incoming call is longer than the duration between calls. So you see these calls coming in quickly, and then you see the longer Salesforce operations taking place. Now, this works, right? Because each API call is a separate execution context. It's running in its own thread. So what happens is that the Salesforce operations are working in parallel. And this is fine as long as the API calls, the operations that are being performed by the integration, are independent of each other. However, what happens if that is not the case? What happens if each one of those Salesforce operations performs a locking operation? Now, they're going to lock the record that's being inserted or updated, but what if there are additional locks going on? So, for example, what happens if you are, say, updating many contacts, but they're all on the same account? Say you have an account that has a lot of SKU. Not a good practice to have a very, very large number of contacts on an account. In fact, it's a very bad practice, but it does happen. So what happens if your integration tries to update many contacts that are on the same account? Well, those are going to lock. And you're going to start seeing that the time that it takes, and if you look at this chart, sort of the light blue is where the Salesforce operation is waiting to gain access to a record. Then it performs an operation. You can see the third blue line, it's a longer wait, performs an operation, but the lock expires, right? And it fails, so you get what's noted in red is a locking error, which is then forwarded back to the integration that says, unable to gain access to this record, it's currently in use. And this can happen anytime where you're updating a record that has a lookup to a common object, is where you start having the potential. The one we see a lot is the sales or marketing automation scenario where an external integration is inserting large numbers of campaign members that are all on the same campaign. So for example, they've done a marketing campaign for a webinar, and suddenly they're getting thousands and thousands of requests, all of them on this webinar campaign. They're inserting the campaign members, and in doing so, the campaign locks because they're all accessing the same campaign, and they start getting these integration lock errors. And we're talking potentially huge failure rates. I mean, we've seen customers that have been seeing failure rates in, the 30, 40, 50% of them are failing. This is a problem that we've been seeing more and more over the past, probably 6 months or so, is where we're seeing customers dealing with this. And it's because they cannot process these records quickly enough. So how do you deal with this issue, right? Both as a customer and as an ISV partner, which is how do we deal with it? Well, one solution is you can say, okay, reach out to your vendors and have them use bulk operations. Yeah, and good luck with that, right? Even if you can convince that integration vendor to do that, it's going to be a significant development process because they've probably built everything to work with individual records, and they have to train to use this slightly different way of using the REST calls into Salesforce. And they'll say, wait a minute, we're doing things correctly. We're doing things according to the spec. Yeah, sure, the REST document, the REST specification says we recommend performing bulk operations, but they're not really warning you about this problem. They'll say it's somebody else's fault. And, that means, usually it means blame the ISV partner, but that's another story. So let's assume that you are not going to be able to convince your integration vendor to fix this, right? Because you probably aren't. If you are watching this and you are an integration partner, by the way, fix this, okay? Do us all a favor. But let's assume that that's not a solution. So what can you do? Well, one answer is obvious: use less time, right? If you can use less time with each operation, then the chances of a lock are reduced. So what might this look like? Well, one way is to go asynchronous. So here, if you look at this chart, you can see how an integration event occurs, and the Salesforce event is kept short as possible, and it defers the operation to an asynchronous operation. And the asynchronous operation, again, then can take as much time as it needs. Now, this is probably going to reduce the lock errors on the integration considerably, right? The problem is that you still have locking functionality going on. You're still updating that contact or that campaign number or that S object. And now you might be doing it both on the Salesforce or on the asynchronous operation, either the synchronous operation or the asynchronous operation, or you might be doing it on both. So you're going to start seeing sporadic, occasional locking errors. And they might occur if the locking error occurs in your synchronous, and that's what that Salesforce line means, it's synchronous. If it occurs on the synchronous part of the operation, it will be reported as a lock error to the integration. If it occurs in the asynchronous operation, well, you may or may not know about it depending on your logging capability. Now, asynchronous operations, this approach has a number of trade-offs, right? If your synchronous operation locks records, then you're going to see fewer record locks reported to the integration. If your asynchronous operation locks records, then you're going to need some sort of recovery system or logging system to detect when those lock errors occur on the asynchronous side. And if both lock records, then you're going to have both of those problems, right? Both of those characteristics. You're going to have fewer integration errors. You're going to need that recovery or logging mechanism. But because you have more total operations going on, you might actually get more record locks total. Another thing to watch for is the number of asynchronous operations. If you fire off a feature call or a queuable for every one of these incoming API calls from the integration, well, that starts consuming many, many asynchronous operations. And you're dealing with a 24-hour asynchronous operation limit on your org as well, which the number varies based on the number of users and licenses and the size of the org. So just saying, let's move some of that logic to an asynchronous context, it doesn't really solve your problem. It just moves things around. Now, here's the bad news. There is no 100% perfect solution to this problem. There isn't, because as long as you have automation and Apex existing on your system, then your synchronous operation is going to take a finite amount of time. It's going to take time. And there is a frequency of incoming API calls that will be able to overwhelm it. So there is no way, there is no solution that I can think of that will guarantee that you will never see a lock error because of this. It's just the nature of the platform. So what we're looking for are ways to make things better. It brings us to the next logical step, which is, well, if we're having trouble handling these high frequency of individual operations, can we turn them into bulk operations? And this is where I invented the term dynamic bulkification. Now, I've been a long opponent to the term bulkification. If you have read my book, you know I say it's an evil word. There should be no code but bulk code. Everybody should learn and use bulk design patterns, bulk Apex design patterns right from the start when you start learning it. And you should never even learn the single record patterns. Now, that applies to writing code. You should not be bulkifying code. You should be writing bulk code from the very beginning. But this concept of bulkifying individual requests, individual API requests, well, that sort of makes sense. And here's what it might look like if you had a way to do this, which is we're going to have our integration call into Salesforce. We're going to have our synchronous operation that's going to be very, very quick. And it's going to do something so that at some point an asynchronous operation can take place that will combine many of these individual operations. So you're basically dynamically bulkifying single record operations, hence the term. Now, this won't always help. Your asynchronous operation obviously would have to be optimized for bulk operations. You know, the nature of Salesforce is that it is really designed for supporting bulk operations up to 200 records at a time. And it tends to be very efficient at it. And there are very efficient design patterns for it. So for example, if an individual operation took 1 second, processing 200 records is not going to take 200 seconds. It's going to take maybe 20 seconds, right? So there is a huge benefit in terms of performance by combining these individual operations into a bulk operation, as long as your asynchronous operation is designed for it. So we're assuming that it is well-written asynchronous code. Also, if your asynchronous operation triggers inefficient automation, which means process builder, then you may not see the benefit either, because as most people know, hopefully you're aware by now, process builder is evil. It is incredibly inefficient. It consumes CPU time like nothing else. So you want to avoid process builder in general. You certainly want to avoid it when dealing with this kind of scenario. So now that you see the concept, the question is, how do we do it? Well, the easiest and obvious and first thought that comes to mind is let's use platform events. Platform event is a feature that hopefully by now most people are familiar with, where you publish an event to an event channel, and that will trigger an Apex operation. You can have external listeners, but in our case, we're really only concerned about Apex, which will receive potentially all of the events that have come in up until that time. So in a way, platform events are self-bulkifying. They're already doing dynamic bulkification without the term, which I get to keep credit for. So there are some caveats with platform events. you will need some sort of backup system because they are not 100% reliable. There are limits that come into play, and there's the potential for service disruptions, which are independent from the platform itself. So now, mind you, they're very, very good. And I think for most applications, they're probably going to be good enough. But you do have to be prepared for the possibility that you might lose data if you're taking this approach. They can fail without notice. Again, this is at this time, this is an area that Salesforce is constantly improving and working on. As before, it's important that your platform event handler is efficient, right? If it's doing DML that invokes process builder, you're still going to be in trouble. And currently, platform events run in synchronous limits, which makes no sense to me. They are an asynchronous operation. They should run under the larger asynchronous limits, but they don't. However, you can, from a platform event invoke a follow-up queuable operation or asynchronous operation to handle greater volume. The other problem with platform events is at this time, they are not ISV friendly. And what do I mean by that? There is a limit to the number of platform events you can have in an org. And that limit is shared by everyone there across the whole org. So if I am publishing a package on the App Exchange and I want to use a platform event, and I include that in my a custom platform event, and I include that in my package, and I try to install on an org that already is using up its quota of platform events, my package will not install. So I run this enormous risk that there is a certain percentage of customers that I will never be able to install my package to. So at this time, I cannot use platform events as an ISV partner. Hopefully, this will change. So the other option is to use an asynchronous framework. Now, I am not going to go into depth of what an asynchronous framework is and how to use it and so on. If you have my Apex book, the 5th edition, I've always had a chapter on asynchronous processing, but you really want to look at the 5th edition one because that covers some of the newer features available in the asynchronous system, including things like transaction finalizers. And you can look there. I'm gonna cover just sort of the core concepts very, very briefly as you need for this issue. But if you actually want to know how to do it, you can look there. The general sense of it is you create an async request object. It's a custom object, and then you use logic to basically look at those objects, read them, and perform the requested operation. And those are executed by way of either scheduled Apex or queuables. So what it looks like is something like this. And what you'll do is the asynchronous operation that's being driven by the framework will occur periodically. And what it will do is it will look for these async request objects that define the asynchronous operation you want to perform, and it will read more than one of them. So it will read, a group of them and execute them all in that one asynchronous operation. So in a sense, what you have here is that kind of dynamic bulkification. So when you look at the chain here, the API calls in to Salesforce, performs a synchronous operation that rather than trying to do the whole operation that's needed, just creates this asynchronous request object that specifies the desired operation. At some point, a queuable fires, could be batch Apex, could be scheduled Apex, that reads these async request objects, reads as many of them as it thinks it can handle, and proceeds to execute them in bulk, hopefully very, very efficiently. So what are the advantages of this? What are the characteristics of this? First of all, it's extremely reliable. Because you're storing the asynchronous request, the operation you want to perform, in an object, if an error occurs, that object doesn't go away. You actually have the object there. You can record error information on the object. You can retry it later. If if the asynchronous request is requesting too much, say it's trying to process too many records, you could split it up into two that maybe you can handle. It's very reliable. You're not going to lose data. You can support all kinds of different asynchronous operations, whatever you want, on a single custom object. So you're not going to get clutter there unless you design the thing poorly. You just have a type field on that asynchronous request object that defines the kind of operation you want to perform. And then you can decide how you want to merge them. So for example, if I have this asynchronous request object that has 3 types of asynchronous operations, I might query only a specific type because I can merge them and run them efficiently when I'm doing this dynamic bulkification. Another advantage is it always runs under the more generous asynchronous context limits, which has higher CPU time, higher heap space, and so on. I do want to note that this dynamic bulkification is new. It's not covered even in the 5th edition of the book, but I'm also, in addition to here, I will have information on this posted up on advancedapex.com. So let's wrap things up. First of all, you may not be experiencing this. And if not, you can ignore this whole session. Just put it sort of as a mark it as something that was interesting, curious, to keep in mind should you run into it in the future. It's something that we're only seeing with certain integrations and with certain customers. The characteristics that are an integration that has high frequency DML operations, high frequency operations into the org, and that those operations, the time exceeds the duration between those integration API calls. And the processing time obviously will vary based on the org. If you are experiencing this, what can you do? The first thing you can do is get rid of Process Builder, right? You want to do this anyway because Process Builder is evil. And I know that sounds harsh, but it really, really, really is horribly, horribly inefficient. Flows are excellent. They really did Salesforce did a brilliant job making them able to handle bulk operations. And of course, well-designed Apex is going to be fine as well. Definitely talk to package vendors. It is, I know, really, really hard to determine where CPU time is being consumed when you're looking at these lock errors, like who's using the time, can be really, really hard to figure out. Debug logs are notoriously difficult to interpret correctly. Debug logs sometimes lie. One tool that I found incredibly helpful is the Financial Force Apex Log Analyzer. Strongly recommend that to figure out where time is being used. You will find when you're running into this issue, 9 times out of 10, lots and lots of Process Builder. We really see that a lot. But do talk to package vendors because we are starting to see this. And of course, it is possible to deal with it. So for example, we have for certain issues, say insertion of campaign members, which is one I mentioned earlier is one where we see locking errors. We have built dynamic bulkification into our application, and it can be turned on very easily through configuration. And what our application does basically is, rather than trying to perform all the operations it wants to do during a campaign member insert, it does the bare minimum, creates these asynchronous request records, and then those get processed in bulk later. So depending on the package, depending on the vendor, they may already have a solution for you. But if those don't work, then you're going to have to put in the work. There are no magic, easy solutions that will work everywhere, as I mentioned earlier, just because at the end of the day, having integrations performing very high frequency of single record updates is not a good thing. It is not the optimal way for an integration to work. And again, if you are an integration vendor, please, please, please look at combining those individual operations into bulk operations. That is what Salesforce was designed to handle. And that is how things will work best for you and for your customers and your fellow ISV partners. And with that, I'm going to turn it back over to Amit. So.
Thank you, Dan. This is such a great session and lots of good information you share with the community. And I hope this will be help to our Epics Hour followers and subscriber on YouTube.